let's get into the big topic of open source, something that we actually say at Red Hat.
We haven't
This is so
we
awesome.
are an open culture that believes in the importance of
What is that process that a developer, or let's say
as the Kubernetes ecosystem really boomed.
Hello and welcome to this week's Ask an OpenShift Administrator Office Hours live stream. I am co-host Andrew Sullivan, joined as always by my other co-host, or the co-host. Yeah, we'll go with co-host, Mr. Jonny Rickard. Yeah, how are you, sir?
I'm good, man. How are you?
It's another beautiful, scorchingly hot, amazingly humid Wednesday here in Raleigh. So, you know,
Right.
I'm happy that the house has solar panels, because otherwise I would be terrified of opening my mail these days.
Oh yeah, for real. I see in the background you've got your little nap bed back there. So
yeah, that's for the it's for the dog, you know. So this is so this picture was the very first dog that I had, the first dog that was mine. You know, many years ago. Gosh, 20 years ago. When he passed, we had an artist commissioned to paint him. But the bed is, if I could orient my fingers, you know, the bed is for our current dog. She's also a miniature schnauzer, and you know, I'm sure if you've seen the stream enough, you've heard her bark before. You know, obnoxious little critters.
Oh yeah, we had schnauzers. When I was growing up, we had nothing but schnauzers. Like they're awesome dogs.
Yeah. They love to bark. They are noisy, without a doubt.
Yeah, they are.
So, what are we talking about today, Jonny? What's the topic?
So this is something I'm pretty excited about. Like I know I've been trying to not trying, but like once it got announced, I've really been excited about having you guys come on. But it's Red Hat Service Interconnect, right? So it's actually Scupper, which is I'll let the guys explain what it is in more detail. But at a really high level, it's a layer 7 app-to-app connectivity tool that if you have multiple clusters, you can connect an app to another cluster, and as a developer or as a user, you can do this. So I think it's something that's pretty awesome. You know, like when we start talking about scale, you know, cluster scale, we have Submariner. Then we start talking about application scale. Now we have Scupper. So I think this is pretty awesome, and I'm super excited about it. If you can't tell.
Thorsten, I couldn't agree with you more. Johnny's looking good over there. I have a little bit of beard envy going on these days. So
yeah, man, it's coming in good. I'm a little scared of it right now. So
you know, we were just talking about how hot it is. You know, summertime beard. You know,
that's right. Well, I'm getting ready for winter, right? I'm really. This is winter prep. So
you live in Texas, Jonny. What winter?
I know. We had a freeze a couple of years ago. That was real.
Yeah, it made like international news. I remember.
It happens.
Well, joining us today is Jack and Justin. So I will start with Jack. I'll ask you to introduce yourself. You know, to use the old Arnold Schwarzenegger. You know, who is your daddy? No, what is your job and what do you do? No.
Nice. My name is Jack Britton. Obviously, I'm a product manager, and I'm responsible for the product side of Red Hat Service Interconnect, as well as a few other products inside of middleware.
Awesome. Thank you. And sorry, Justin.
Hi, I'm a manager for the software engineering group that produces Red Hat Service Interconnect and works on the upstream project, Scupper.
Awesome. Well, thank you both for joining us today. And I always like it when, you know, the engineering folks point out that, you know, software manager for the upstream, the open source project Scupper that's associated with it, because it's always a good reminder that, you know, everything we do is open source. It's all upstream. We just, you know, bring it down and support it and do all of those things. So thank you for that reminder.
Yep.
So as always, you know, we start off the show at the top of the hour with some top of mind topics and chat about a few other things. So I know we actually have a fair number of things here on the list, Jonny. So we should probably go through relatively quickly so that way we can give all the time that we can over to Service Interconnect. So I'm going to prompt you. I'll ask you to start with the OCADM commands that our Hope 9 had sent over to us.
Yes. So let me go ahead and share my tab really quick. All right.
You're gonna have to zoom in a little bit. Yeah.
Yep. Is that better?
Yeah. You can probably make your window taller. That might help.
Let's see here. Yeah. I don't know if I just made it worse actually.
That was wider.
Yeah. This is just gonna happen. All right. So within and so I was trying to figure out where these commands were deployed to, because I had the 4.12 client, but I just installed the 4.13 client earlier. And if we take a look at OCADM -help, we've got a couple new subcommands here. So we've got wait for stable cluster, and then we've also got this wait for node reboot. Now this is pretty cool, because if you run wait for node reboot, what you can do is you're just essentially waiting for the nodes to come back up. But say if you want to reboot a machine config pool, so you can actually reboot all of your machine configs through this command. And rhope9, thank you very much for sharing this. This was really awesome. It came through a knowledge article for the certificates for when we had the FIPS mismatch. So yeah, if you wanted to, or if you needed to, you could reboot a machine config pool by running like OC80. I'm not going to run this because it would actually break stuff, but you can say all. You can define like which nodes, or you can say, hey, I want to define, or I want to reboot the workers. I want to reboot the workers and masters, or you can actually throw like a -a or minus node or whatever, and then do all. And then the other one is like just waiting for the command to come back up, or waiting for the cluster to become stable. And yeah, so it's essentially just going out and waiting for OC get cluster operators to look like this.
Yeah, I see that one being very handy with automation.
Oh yeah,
100%. If you're using Ansible or something like that in order to go through and deploy clusters. And the node reboot, that's an interesting one, because I've been asked a number of times by folks, how do I trigger the nodes to reboot for whatever reason? And historically, the answer has been, we'll just create a machine config that, changes something minor, an unimportant file, and apply it. And that'll go through and cause each one to reboot. So it's good to see that we have something that helps make that process simpler.
Yeah. Well, and it's cool too, because like thinking about automation again, right? If you say you want to reboot your nodes every Sunday, right, or every other day, I don't know, you could set up a cron job to actually run that command for you and actually do that, and then have the wait for the cluster to become ready, to wait for the cluster operators to come back up. So it's pretty handy.
Reboot nodes every Sunday. What is this? Your Wi-Fi? Come on.
I know, right? my Wi-Fi is like every other day right now. So.
Yeah, networking, all these things. It's finicky.
So frustrating.
Let's see what else have we got on the list here. I saw, what is today? Wednesday. So Monday, the upgrade path for 4.12 to 4.13 on stable was released. So for anybody who has been waiting for that, I know this one was unusually long. It was 70 something days, I think. But there was several weeks of delay due to the FIPS issue that happened. So if you ignore that, it falls right into the normal range for when we do the upgrade path promotion. So anyways, sorry while I cough and not do it in everyone's ears or speakers. So anyways, if you have been waiting for the stable upgrade path in order to update your 4.12 clusters to 4.13, now is the time to do that. I also bring this up because OpenShift 4.10, the EUS version, is exiting support in less than a month. September 10th is the last day for support with 4.10. So I definitely very highly recommend, and I hope that you have already been looking into your update path on that. Remember, with EUS releases, you can do a, what do we call them? Fast update, Johnny? Accelerated, whatever it happens to be. So remember, where you go in, you can pause the worker or compute machine pools. You update the control plane from EUS to EUS, so 4.10 to 4.11 to 4.12. And then you unpause the compute node machine pools, and they do a single reboot up to the new version. So definitely a good one. Definitely a good time to be looking at that, depending on which version you're on. Let's see, I got two other short ones here, Johnny. So one, NUMA aware scheduling went GA. So if you looked at the everything you need to know about 4.13 blog post that I'll type in here, it mentioned NUMA aware scheduling, but it was not yet GA when 4.13 was released. So I think it was late last week that was officially released, officially announced as GA. So you can take advantage of that and be fully supported. So also an important one. And last but not least, IPI with an external load balancer. So I did not know this. I was just recently digging through a couple of things. Somebody had asked me a question and said, "Oh, why was the installer changed so that IPI, so specifically vSphere IPI, I no longer have to provide VIPs, the virtual IP addresses?" And it's because you can provide effectively a subnet, and it will deploy. So the thought process here, and it's a little clunky and it's a little suboptimal, I'll say. So I create a load balancer, an F5, an HA proxy, a Citrix, whatever. And I point that load balancer at all of the IP addresses that are in, say, a /28 or a /29. And now I can take all of my infra nodes and my control plane nodes, and I put them all into that one subnet, and it'll load balance that particular cluster. I don't have to provide a specific VIP, right, to come up with IPI anymore. So I thought that was really interesting. There's a couple of different ways you can take advantage of that, right? Day one, you deploy the cluster into that one subnet, and then you add day two, you add a new machine set that's outside of that subnet, so that way you can do all of the things and all of the stuff. But it's one we should probably explore that one a little bit.
Yeah, that sounds cool.
Yeah, I was very happy to see that we no longer are required to even configure and deploy that internal load balancer anymore with IPI.
Yeah, especially because 90%, at least 80%, right, of people have their own. So yeah, that makes total sense. I'm glad we did that. It does sound a little weird though on using it. So
yeah, from what I understand, they are working on some more, I'll say, streamlined ways. Putting in this whole /28 or something into a load balancer config seems a little.
much.
Yeah. But, if you need it, you need it, and it works when you do it that way. So.
Yeah.
What's the last one? Oh, Kubernetes 128. I don't know. I saw the announcement, but I didn't look at it. Is there anything we should know about there, Jonny?
Yeah, I didn't dig into it too deep, to be honest with you. It's something that we can do next week on the stream, where I spend a couple minutes just kind of going through the enhancements. But I just wanted to make sure that everybody knew that 128 got released. It's called Planternetes, which I thought was a pretty clever name. I love all the project names for the releases. I think they're just getting better and better. Yeah, so next week, and the last thing, Andrew, is just the schedule that we've got coming up, right? So we've got GitLab coming on next week. So they're going to talk about their operator on OpenShift and some of the tooling within that. And so we'll kind of talk about GitLab's capabilities with some of the capabilities that we at Red Hat have with OpenShift pipelines, and not necessarily do a head-to-head with it, but just kind of, hey, here's what we got, here's what they've got, and then just kind of talk about it. Because GitLab's an awesome product. They're an awesome company, and their operator, it's been around for a while. But OpenShift support, I'm glad to finally see it's become a first-class citizen with them.
Yeah.
So excited about that. And then we have Jonathan Gershader coming on in early September. Not sure exactly yet what we're going to talk about, but that's going to be pretty cool. And then we had some internal teams at Red Hat do some development on dev workspaces and incorporating Ansible. And so they're going to come on and they're going to talk about that, because I think that's really awesome that they did that. And it just kind of shows.
Can I use Lightspeed from within dev spaces to?
I don't know. Maybe that would be awesome. That would be really awesome. But yeah, it just goes to show that the community it's the community, right? It's not just Red Hat, and it's not the community. It's the community, and so everybody's giving back, and so they're going to come on and show off their stuff. And then finally, at the end of September, we've got Ortwin Schneider, the legend Ortwin, is going to come back on, and they're going to talk about mesh, service mesh, and mesh lab, and all kinds of awesome stuff. So stay tuned. We got a bunch of good things coming up, and we're working with some other partners and teams at Red Hat to come in and do the stream as well. So stay tuned to the schedule.
Got a bunch of stuff. You saw. I haven't had time to respond yet, but the performance and scale team reached out, so that's going to be a good one.
My man, I was so stoked about that. I actually have the email up. I'm ready to go on that one. So,
Quay 3.9. No, we haven't talked about that. Our Hope 9. I missed that announcement. That's good for them.
Wow, that's bad.
Yeah. So we'll show that up there. So anybody who is using Quay or Key, depending on which English you prefer, All right, I think that's the whole list.
Yeah, that's it for me.
Yeah.
And our hope now, you're late and we called your stuff out. Like we actually brought up the OCADM commands that you shared, so you missed all of it. I did a terrible job explaining it, but just wanted you to know that we actually did it this
Hey,
time.
your demo actually worked, Johnny.
It's because my Wi-Fi dropped in the pre-meeting. That's why. Everything broke right before I logged on. So.
All right. So let's talk about Service Interconnect and what is Service Interconnect. Kind of what are the use cases? Where do we see people using Service Interconnect? And just a bunch of different stuff about it. And I admit that this was one that initially I didn't pay a lot of attention to because it's targeted at, I think a lot of times, or the language around it rather, is used for developers and helping developers connect different parts of their applications across all of the different places that they might be running. I think that's an interesting concept. I think it's something that is very, very important in this day and age. One of the things that we talk about with OpenShift virtualization, right, Johnny? You remember when Ian was on of, hey, bring your VMs into OpenShift so that way they're direct and native peers. They're on the same SDN as all of your containers, and something like Service Interconnect, Scupper, kind of solves that problem for you in the same way that maybe I'm an ultra nerd. Things like Tailscale, right? I put Tailscale on my phone and I can use it with the stuff in my house and I can use it with stuff, right? And it just creates this ability for all of my things to talk with all of my things, regardless of where I'm at or where they're at, as though they were all local and adjacent to each other. So I'll quit rambling. I'll let Jack and Justin, the experts here, kind of walk through some different things about it. But this is really interesting and really exciting to me. And I think it's something that we wanted you all, our audience, to know about because it provides some interesting capabilities that we see beyond just OpenShift and expanding into the applications that are on top across the entire infrastructure.
All right, I guess I'll kick it off, and I invite you all to pepper me with questions. So here goes. So first thing at the outset is just to reiterate what someone said here about the name. So the product name, the downstream name, is Red Hat Service Interconnect. The upstream project is called Scupper, and you can go to scupper.io to check out everything we have there. I'm going to refer to it as Scupper throughout this presentation because that's easier for me.
So less words.
Yeah, exactly. And I think Scupper's, it's as a name, it's more fun. So I consider these the essential things you should know about what Scupper is. Scupper is an application layer interconnect for services. The application layer part is important because it's one of the unique things about Scupper. Most of the existing interconnect or networking technologies are infrastructure layer, but Scupper is different. It's really in a very pure way. It operates at the application layer, and that's what enables a lot of the ease of use and the flexibility of its connectivity, even in the face of existing sort of network isolation and networking challenges.
And so when you say application layer versus infrastructure layer, what does that mean to you?
It means that it's not IP networking. So the process by which the traffic is routed does not use there's a transport that rides on top of the layer 3 networking, but fundamentally the content is transferred using concepts at the application layer. So we're not using IP addresses to route the traffic to the components of your application. We're using strings that identify places on the network that can consume that content.
Okay. So would we consider that like a layer 7 type of, the equivalent in my head is like layer 7 load balancing, right? I don't know if that's an appropriate analogy or.
It is like that. It is. We say it's layer 7. I think that's correct. There's some people on the team don't like the traditional layer terminology. I'm one of those. I think it's slightly garbage, but I think layer 7 is the conventional way to talk about it. Yeah.
Yeah, our Hope 9 asked an interesting, is it more like Kafka topics?
Not really analogous to Kafka topics. It's more analogous to, if the tailscale was more correct, right? Except that tailscale needs sort of an intermediary and Scupper doesn't. Right, so.
Okay, interesting.
So Justin, just real quick, if you wouldn't say, or if you don't like the layer 7 description, how would you describe it?
I prefer the term application layer, right? So most networking operates at the infrastructure layer.
Yep.
Yeah. So what I like to tell people that depending on where you sit in the technology field, you get wrapped around the axle over layer 3 and networking and stuff like that. Of course, all that stuff is taking place, right? But Scupper sort of abstracts all of that from you. That's why it's an application layer. You're concerned about what you call something that is a service and that it can connect to another service, right? So you don't have to worry about stuff like CIDR conflicts or what your local subnet is or what the subnet is on the other side. So it is truly application layer in that aspect, right? People like to get into some contention because the other networking bits, all the way up and down the OSI stack are still happening. You're just not concerned about them.
And the fundamental basis for communication in Scupper is a mutual TLS connection, a link between sites, right? Mm-hmm. So what that means concretely for users is that if you can make a connection, if you in at least one direction, you can establish that mutual TLS channel, and then the application's view of connections, they ride inside that channel. It's like virtual TCP connections.
Got it. And I suspect that you're probably going to cover this, in a slide or when we do a demo. But I know that one of the things is firewalls don't get in the way, right? All of these other things, and I assume that that's because much like things like Tailscale, it reaches out so that it's not something reaching in; it's it reaching out, and then something brokering that connection together, so that way they're able to seamlessly connect.
That's right. Yeah. After you establish that mutual TLS link, we call it a link, then traffic can flow in either direction.
Got it. Yeah, I know as someone who used to have to fill out requests for firewall rule exceptions, that is very nice. Jonny, you laugh. You filled out those too. You remember that?
The gray hair in my beard is actually like flashing right now because of that. Yeah, I used to hate those things.
Well, I mean, I know this is a slight digression. I want to come back to the what is it, but that's a really important point, right? So Scupper, for people who operate infrastructure, if you're a cluster admin, right? So it's very interesting because from a security perspective, Scupper is unique. You're not connecting whole clusters. It is not a cluster interconnect, right? Mm-hmm. You are connecting the components. You're creating a network that is dedicated to a specific application, and only the components of that application can communicate, right? And you actually set up that network when you stand up your application, you set up the network at the same time. And when you're done with that application, if you no longer want that application, you tear down the network. So what that means for somebody who might be operating your network is they didn't have to create a firewall hole. And they don't need to keep track of when they need to get rid of the firewall hole. Like that doesn't need to take place.
I think that second one is really important. Like it sounds like when you just say it sounds minor, but it's really important because how often do we forget to tear down those firewall holes and then you have something that's open? So yeah, that's really cool. Our Hope 9 asks, are the links one-to-one, or can you reuse a link for a second interconnect?
I don't quite understand. Is it one-to-one? Well, I'm not sure if I'm answering the question quite correctly. What you need is all your sites to be reachable. It's not true that you need a full mesh. You don't need every site to link to every other site. You just need each site to be reachable through the topology of links.
Okay, I think I understand that. I have manager and marketing in my title, so sometimes it's a little sketchy for me.
It's like doing laps and then you touch it.
I used to
So-
say, so my previous role, I was a technical marketing engineer. So I used to say, I was 2/3 accurate and 1/3 full of it, and I would leave it up to the audience to figure out which third. Now I'm a technical marketing manager, so now it's two of those words are. Anyways,
Let me try again. That question might be about how many, we call them application networks. How many application networks can you put over a single link? And only one, right? These application networks they use dedicated infrastructure. Our data plane is based on these application layer routers. Each application has dedicated routing resources, data plane resources, and that's important because that means that it scales horizontally, and that you have very good isolation of this network, right? So you have full process isolation. You're not sharing data between different applications inside the same process.
Yeah, is the story behind that, like when you're talking to a security engineer, right? Is it like, look, my blast radius is minimized because I'm on a point-to-point, right? Like because I'm not exposing my entire cluster on either side.
Yeah.
I've reduced your blast radius by X amount, and that's why we do it this way.
Yeah, totally. It's highly compartmentalized by design.
Okay, got it. We had a question from Nerlet, and I apologize if I butchered your name. But how is this different from multi-cluster service mesh? I actually got this question yesterday.
Yeah, it's a good question. So I'm going to start with just talking about how it's different from service mesh, and then I'll talk about how it's different from multi-cluster service mesh, right? So it's different from service mesh because it has a different mission. Service mesh is built to use existing connectivity to add behaviors that people care about: traffic shaping, authorization, all these things that you might want in a service-oriented app. Good. The difference to Scupper there is that Scupper is totally about connectivity. It's about connecting things when it's very difficult to make them connect. Right. It's my second sentence here. Scupper connects services in isolated network locations, and that's its reason for being. So what's the difference between Scupper and a multi-cluster service mesh? Well, the way multi-cluster service meshes are typically built is that you have a gateway that will basically forward normal layer 3 connections through to a remote cluster. That's not what Scupper is doing. Scupper is actually creating that mutual TLS transport and then transporting virtual TCP connections over it. So it's really, when you're using multi-cluster service mesh, you're still relying on infrastructure layer networking.
Yeah.
It's still using basically existing networking capabilities rather than building this isolated network on top, which is what Scupper is doing.
Yeah, I don't know if this is accurate or not, but in my head, the way I break up the difference between Submariner multi-cluster service mesh and Scupper is Submariner is more like OSPF and multiple, autonomous services where it's able to route across and between different things at the network layer. Service mesh is like an SDN that's riding on top of something where it's able to communicate across these different things, but also add all of the value of service mesh with, being able to see the traffic and introspection and everything else that's inside of there. Whereas Scupper is more like, I have these components, these things that are scattered around, and they're all going to reach out and say, I need to talk to X, or I need to talk to Y, or I need to talk to this. And it doesn't matter about anything that's underneath it. They set up a session between themselves in order to be able to communicate.
Exactly. And it's about that decoupling from the infrastructure.
Well, good. I feel like I did pretty good for that, coming up with it mostly off the top of my head.
You did.
That was really good.
Yeah.
I'm proud of you, kid. You did good.
Even a blind squirrel gets a nut every once in a while.
And then my last, one more note on service mesh. There is two more notes actually. So both Scupper and service mesh provide TLS authentication and encryption, right? So that's an area of commonality, though they differ in other respects. And then the last point I'll make is that it totally makes sense to use service mesh in combination with something like Scupper, because if you have, because it might be difficult to set up a gateway, a multi-cluster service mesh gateway in a certain location, you can say, okay, that's fine. I'll use Scupper to make this remote database available to my service mesh. It's a good use case.
I was wondering about that. So I tried to Google it and find out, and like the answers were kind of mixed on if you can use service mesh and Scupper. So I'm glad to hear that you can, because it does sound like it would be a good combination to use together. And I can see a bunch of people trying to do that together, right? Where, especially where you have like, there's the zero trust stuff that's coming out, right? And the pod A, if pod A needs to talk to, it's very explicit, right? Pod to pod communication or namespace to namespace, whatever. And then having something else on top of it where I can maybe reach out and talk to something. So I'm glad to hear that you could talk, or that you can use both of those, because from what I initially found, it didn't seem like you could, but you're saying it can. So
yep, absolutely. And then the last thing that I think is important to know about Scupper is that it is cross-platform, and that's relatively unique for this kind of offering. A lot of the similar technologies are focused on OpenShift or Kubernetes, that kind of platform. But Scupper is by design something that will work on container engines, works on it'll work with bare metal or virtual machine processes, and obviously with Kubernetes. It does not support, that's basically what we support right now. But in principle, Scupper could add support for other emerging platforms in the future. So that's part of its mission.
I think I like that. And what comes to mind is I've been asked multiple times whether or not we can extend things like service mesh across virtual and physical platforms. And by service mesh, I mean specific implementations like VMware NSX. Can I use NSX as the service mesh with a cluster that is, spanning multiple different platform types or infrastructure types? And it's because, much to the point of Scupper, they want to be able to interconnect. They want to be able to connect the application components that are spread across those things together. And Scupper solves that problem for us. We just got to be able to use it appropriately.
Yep.
So I'll also ask my default question here. Like, air gap disconnected support, like as long as you can get the images in, it all works fine, or is that a roadmap thing?
No, that is something we do support.
Okay, awesome. And then one last thing, because I just thought of this. I'd seen a comment in one of the Slacks I'm in where people were using Scupper with Podman at the edge.
Yeah.
And so I'm like, oh, that's awesome, because you've got your cluster, and then they've got like their edge component, and the edge component can reach back via that I want to use the right term that you used earlier, the application tunnel. Is that what it was? That tunnel.
We use the term link. Yeah.
Link. Yeah. So via that link, that edge component can reach out and either push what it's collected out, back to the main cluster, or pull stuff in over that. So I think it's awesome.
Yeah. Absolutely. Yeah, that's that cross-platform stuff is one of the things that's most exciting to me, and it's because of the effects of it, or the impact of it. It means that a lot of people who were considering making a migration but then stopped in their tracks because there's some part of their app they can't move, or some legacy system that has to be involved. It means that now you can migrate almost everything but the stuff that you can't move, and your application will work. You can achieve this migration. So it brings more modern tooling to a larger audience.
Yeah, that's huge. It really is.
So I think we've talked a lot about a couple of these things. So it runs on lots of different platforms. It's also something that scales up and scales down very well. So it'll run on large clusters, and it'll run on small edge devices. We've been talking about how it's an application layer solution. We often use the term over the top as well. So you don't need to change your existing networking, right? That's basically the whole story. All you need to do is, well, the one proviso is you need to be able to make a connection in at least one direction to establish the transport. After that, you're good, right? It is protected. It has a security model. It is, while I think some people feel some anxiety about it, it has considerable merit because it has a higher level of isolation than you get from alternative technologies. So it's this interesting thing, right? So Scupper is something that enables application owners and developers to create networking across sites. And that's new. That's a capability that hasn't been available to application owners before, right? That used to be centralized and controlled by the infra team. So that can be scary for some, but it's also doing it in a way that is highly isolated, and we're doing it in a way that gives the cluster administrators the ability to control the guardrails. So concretely to control how sites are linked and what services are exposed, right? And it's I think I had a third point there. Oh, and it basically what it can do is if you can enable app owners to deliver apps faster, you can get the infra team out of that sort of blockage, that point where they can't handle app owner demands fast enough to help companies turn around new software projects. If you can streamline it by using something like Scupper, you set your guardrails and you enable your app owners and app teams to deliver their applications under their own control, then that's very interesting.
Can I play devil's advocate for a moment?
Please.
If I am an administrator who is, for whatever reason, valid or not is not the point, against using something like this, is there a way I can block it or prevent it?
Yes. Yeah, there's when I said guardrails, it's the technology is to introduce a custom resource into your cluster that will by default prohibit all links between sites.
Okay. What comes to mind for me is the difference between DNS over HTTP and DNS over TLS, right? DOH is port 443. It's not like you can block port 443 at your, the site level, because that kind of breaks the internet. But DNS over TLS uses port 853, I think. So if you want to, blanket disallow or prevent DOT from working, you just block that port. So it's, again, we can talk about the merits of something like that or the, valid, invalid reasons, but it's good to know that it is a possibility if you would want to. rhope9 asks, what kind of audit logs can Scupper provide?
It produces Kubernetes events. That's one thing you can monitor. The data plane component, the router itself, produces logs that you can use for audit. What we don't yet have logs that are specifically tuned to auditing needs, and that's a roadmap item for us, basically. It is possible to understand what people are doing, what links people are creating, but right now you need to understand the data plane.
And there's not traffic analysis or anything over those links, right? Like it's not doing any sort of packet inspection or anything like that at the Scupper level.
No.
Got it.
Right.
Yeah, and being MTLS, man in the middle and stuff like that doesn't really work.
Right.
So have you been on some of those conversations with like security teams? Like I'm just curious about how, because I can only imagine when they're like, I can't control the network getting created. I can't, I can only imagine like the fear, especially where I came from, where Andrew and I came from. Like there's, I can imagine that conversation being very, very.
Interestingly enough, most of our customers are banks.
Oh, very nice.
So they, at a few of these banks, we've gone through some pretty rigorous testing by the banks themselves, right? So evidently you can overcome those concerns. So
yeah.
Yeah. So Unix Daddy asks if we'll end up with a number of sidecars, which I think is a comparison against service mesh, right? Service mesh stands up a number of sidecars to join the pods and all that other stuff. I don't want to answer for you, but I think the answer is no. I think it's initiated from within the pod.
Yeah, there are no sidecars in the picture with Scupper. There's a data plane component called the router, and you'll see that. And that router basically opens listeners that are local to listeners and connectors that are local to a namespace to enable communication.
Oh, interesting. Local to the namespace.
Yep.
Very cool. I feel like we're just several of these, probably many of these questions will be answered when we get to the demo part. So I don't want to hold this up anymore.
Well, and I'm sorry, I know you just said that, Andrew, and then I was just going to make another quick point, though. I think just on top of this, right, like anything without all this stuff is like not all the concerns get met, but a lot of these things are mitigated when you implement good RBAC as well, right? So say you have service mesh, right, and say you have Scupper, and you can use RBAC and controls to say, hey, I only want certain people within this group to be able to create networks, right? So then you have like this tiered administrator, right? So that way it's not just Johnny's an admin and Johnny can just go and do whatever Johnny wants to do no matter what with no consequence, right? It actually goes through a workflow, or maybe you use some type of CI/CD pipeline or some type of GitOps pipeline, and you have a service account that does it, and your actual people can't do it. You know what I mean? Like good RBAC and good security mindsets can help offset any of those concerns, right? Where it's not just that free for all kind of wild west. It's legitimate things getting created when they need to be.
Yeah, no, yeah, exactly. And like the fundamental technology here, because it's over the top, very much enables app teams to take a lot of control here. But we've also added in what I call the guardrails or controls that allow the cluster administrators to limit and in fact completely prohibit the use of Scupper for creating these networks. So what you do is, your organization is going to change over time. The degree to which you trust the individuals or the teams might change over time, and you can reflect that in the controls that you apply to the cluster.
Nice. All right. Well, I won't hold it up anymore. I'm super excited about Scupper. I think it's great. Like this I think is a long time coming, and from somebody that's been part of like no engineering organizations for a long time because of things like networking, like it's cool to see something like this finally coming out where it enables teams to do things. And so this is like super nerd stuff for me, so I'm excited to see it.
Sure. Yeah. So my last point is that it's easy, and I'm going to show you how easy it is. So I guess we'll get on to the demo if folks are ready.
We're ready.
All righty.
It's not Johnny giving the demo today, so we should be fine.
That's right.
Yeah.
I'm ready for you.
One of these days, you're going to get tired of me harassing you about that, Johnny.
I will never get tired of it. I own it 100%. It just makes the good days that much better, So
I'm going to share my whole screen for this one. You ready? Okay. So I've stood everything up, and we'll start by looking at the console here. So I have a very simple application. Oh, and by the way, I can't see the questions at the moment, so please help me out if any come in. So this is the app. It's a hello world. This app has two components, as a front end and a back end. The front end is what you see now here. It serves up the HTML and so on. And the back end it will reply to greetings. So we can say hello to the back end, and the back end will say hello back. And in this case, I've set up, I have Minikube running on my under my desk here in New Hampshire, and I have an OpenShift instance running in Dallas.
So Minikube implies OpenShift 3.11,
right? No, this is upstream Minikube. So here it really represents any flavor of Kubernetes.
Yeah.
Okay.
It does work with OpenShift 3.11. Okay, so that's pretty simple. And then my app, I just want to show you it's working. So you can see that the back end is called Wacky Worker, And the front end, our name is Spectacular Sparrow. We can exchange greetings. So now I'm going to tear all this down, and I want to show you how what the process is to set this up as an application owner. But first, let's take a look at what I've got running here. So this is on the right-hand side, I have OpenShift, and on the left-hand side, I have Minikube. So what's running? Here I have the back end running, and here I have the front end running. You'll note that the back end is not running on OpenShift. That's the magic. And then to go a little further here, I look at the services. So we have actually here's where we want to see the services. All right, here we go. While we don't have the backend pod running here, we do have a backend service available. This is a standard Kubernetes service, and it communicates by way of the Scupper router component.
And I'll point out that the cluster IPs there are completely different subnets as well, which helps to identify that they're different clusters.
Indeed, right. So what I'm going to do is I'm going to delete Scupper, get it out of the picture, do it in both locations. So now all I've got left here is my back-end workload and my front-end workload. So in Scupper world, everything happens in, there are basically two big phases to achieving my hello world. The first phase is to initialize and then link the sites. So I'm going to initialize this site, and I'm going to, I've seen the console, so I won't run that. I'm going to initialize this guy. This is going to start the router and the controller for Scupper in my current namespace. Sorry about that. And here on Minikube, I'm going to do the same. On the Minikube side, I'm going to set ingress none because I don't need to. Ingress refers to those links. I don't need to make a link into my Minikube site. Indeed, I cannot because it's behind NAT on my home network. Instead, we're going to go the other direction. We're going to link from the Minikube site to the OpenShift site.
So by doing the Scupper init, you're setting up that cluster, the one on the OpenShift cluster that's hosted in, I think you said AWS, to act as the receiving side for new connections to be initialized.
That's right. For new links, just to clarify, because it's not application connections, it's the transport.
Got it. Okay. Right. Yes. Terminology is important. Thank you.
Right. Okay. So now what do we have here? We have our front end workload, and then we have the router, and we have the controller. All right. So we've got our site infrastructure. And then over here, it's going to look very similar. The backend workload, the router, and the controller. Now we need to create that link. These sites still aren't linked. So the procedure for creating a link uses a secure token. So the site receiving the link will generate the token. So it's Scupper token create. Secret token. Where I want. And then on the other side, so I'm doing this from the same machine, so I don't need to transfer that token, but if you were using the CLI on different machines, you would need to transfer it. Yeah. That token represents it identifies a site, a point at which I can create a link to, and it also represents permission. And by default, these tokens are single use, and they're time limited by 15 minutes, and you have control over those parameters. So I'm going to create a link. Okay. Now I'm linked. So that's basically phase one. It's about creating those links. Phase two is choosing services to expose. So what I want what I need here is I have a front end. That front end code depends on calling into a back end. So I need that back end service to appear here, but I don't have it. On the site that owns the backend service, I'm going to do Scupper expose backend 8080. Now you can see I've got that backend service. That means our front end can now call the backend, and it'll communicate across the link.
And so I'm piecing things together. So on the destination side, so the OpenShift side, which is wanting to reach back to the Minikube side, effectively that backend service, it's actually pointing at the Scupper router pod. And when the front end in OpenShift, the right-hand side, talks to that backend service, it talks to Scupper. Scupper routes it across and into the Minikube side that's residing there locally. So it's, I won't call it a proxy, but you're not having to do things like, and I know you pointed out this out before, but you're not having to do things like advertise a subnet or something like that. You're not doing like weird networking things inside of that namespace that's running in OpenShift on the right-hand side. It's just a service, and it gets consumed like any other service inside of the cluster.
You got it right. Exactly right.
Dang, that's awesome.
So Nerlep, I think the question that you're asking there, so does OpenShift apps endpoint have to be in a public hosted zone to establish the Scupper link? I think the answer to that is Red Hat Service Interconnect. The point of, and Jack, this is probably a question for you, right? The point of Service Interconnect is to provide that what I'm going to call the broker, right? The thing that Justin stood up doing the Scupper init on the OpenShift cluster hosted in the cloud.
Correct.
Yeah, so that way you can have, in your environments, none of your environments have to be exposed. You use Service Interconnect as that part where, let's say that the OpenShift cluster was running in my house and the Minikube cluster is running in Justin's house, right? We don't have to expose anything out to the world to allow that connection to happen. We rely on Service Interconnect.
Except for one thing, right? So just to make sure that if you look at something like Tailscale, that everybody reaches from the inside out because there's a third-party intermediary somewhere, right? Mm-hmm. Nobody has to have an outside-in connection. You have to have at least one for the time where you make the initial connection.
Yeah, that's for the link, right? You need in this case, we're making the link from the left side, the Minikube side, to the OpenShift side.
So there was an ingress on the OpenShift side.
Precisely.
Over TLS, and that's the only one.
Exactly.
Okay.
And the thing to call out here too, right? Like this is a perfect example of edge to public communication, right? Like this is a perfect example of edge communication, right? Because I think when we do a lot of these demos and stuff like that gets lost in translation. This is your machine at home behind NAT and behind your router gateway and all that stuff, right? Like just sitting under your desk, and then that's OpenShift out in the cloud, and you've got the link going back to where it can make that secure connection back and communicate over that. And that's typical of what we'd want on an edge connection, right? It's something where either we want the edge machine to reach out or we want something to reach in and get something, right? I think that's pretty awesome. Dang, that's awesome. Do you have to use the Scupper CLI for everything, or like is it all in YAML and I can just apply YAML?
Yeah, so we also offer a YAML interface. The YAML interface right now is quite good for configuring the sites. The service exposure part, we do have an interface for it, but we don't love it. So we're working on improving that for our next release.
Okay, awesome.
I already know where you're going with that. You were going with that, Jonny. You're thinking GitOps.
100%.
Yes.
100%.
Yeah, we very much want to enable GitOps. The tricky part is actually the tokens.
Yeah.
So generating the token in the links is not possible in a completely declarative fashion because you don't know the ingress point in advance. right? So you need at that point you want to use automation. You want to use a tool such as Ansible to generate the tokens and the links.
Yep. Combination of jobs in Ansible or jobs in some CI/CD pipeline. Yeah.
So a couple of questions just occurred to me. So one, that the ingress is not a where the connections are established or the links are established. It's not a part of the data path. Basically, once the link is established, it gets out of the way.
Right.
Exactly. Yeah.
And then, do you have any idea of overhead associated with it? When we think of service mesh adds, I don't know, I think we say 3 milliseconds of latency. There's also some CPU overheads, stuff like that when using it. I would assume that because we're doing encryption, stuff like that, there's probably a little bit of CPU overhead based on the amount of traffic, but otherwise,
there's some math available, not off the top of my head, that we have that can help you calculate the CPU overhead, right? And we're still sort of waiting on the Scale Lab to help us figure out exactly what the latency is communication-wise.
Okay.
That's a good point, Andrew. That's really, because I think that was a big misnomer early on with service meshes. A lot of people thought service mesh was free, and it costs in CPU.
Free,
Yeah, totally. Yeah. This isn't free either. What I always say to this is that this is so easy to try. You should try it for your use case, and see if it can meet the load requirements that you have.
Yeah.
To go into subtleties here, the data plane component is this router guy, right? Not that one, but this router component. So the amount of CPU you supply to the router component affects the latency of the operations. So you basically can dial up or down the router resource in order to make sure you get the performance you require.
Very nice.
Yeah, our Hope 9 brings up a good point of service mesh is more than just connecting two endpoints together. There's a whole bunch of other stuff that gets added in there, which Scupper does not provide, which I think we said before. Sometimes it makes sense to use both of these things together.
That's right. And Scupper's just it's all about connectivity.
Yeah.
So and I don't know if I don't know if you can answer this or not, but are there plans to integrate Scupper? Maybe not like a direct integration, but maybe like a plugin to Service Mesh or Service Mesh to Scupper, to where you maybe can take advantage of something like Jaeger or something like that?
There are a couple of related discussions we have there. Nothing concrete right now. There is a lot of interest in generating Jaeger style metrics, distributed tracing metrics that out of this that people can use to track applications. And the great thing about that is it's a standard format, and it can tie into standard tooling.
Yeah, going back to the resource overhead, I think that's where a lot of the overhead for a service mesh comes from, is generating all that Jaeger stuff. So
I regularly meet with the PMs for Submariner and service mesh. And we all talk to each other about what the future ought to look like, right? So we are one company. We want those things to all work together and side by side. So eventually we'll get to that business of making them work easier together.
Yeah, I think, and Jack, you said something there that I think is really important, is that you talk with your peers and interact with your peers on that regularly. And I think, when we think about modern applications, we all live, in OpenShift world, in Kubernetes world, and Jack, Justin, y'all are you are probably more keenly aware that most applications aren't all Kubernetes based, right? They span virtual machines and physical servers and multiple sites and all of these other things that we tend to forget about in this, happy rainbows, puppies and kittens, everything is Kubernetes, cloud native, container based world. And that's just not reality. And so making sure that as applications are iteratively modernized, or in some cases, components are never going to be modernized, right? How many of us have applications out there that are running on, Windows Server 2012 or, heaven forbid, 2003? and all kinds of things like that, where the person who maintained that or created that thing left the company a decade ago, and it hasn't been touched since, but it's some critical thing. Think of all the memes and stereotypes and cliches about I don't know what this does, but if I comment it out, everything breaks, type of thing.
Yeah. So speaking of like off cube stuff, I've got one more part to this demo that I'd like to show you. We've connected Minikube, but let's connect something else as well. I've got here. I actually need to delete my previous setup here.
The question is, has it been less than 15 minutes, and can you use the same token?
No, because it's a single-use token. I have to generate a new one. Yeah. Oh, okay. So I have my backend here running in Podman. So the challenge is, can I get this guy connected to my OpenShift instance as well? And I think so. So what we'll do is we have to create a new token. Oh, sorry. First, we have to init this. So I need to say at the outset that you have to put the command in Podman mode. So the easiest way for me to do this in this environment is to say export platform equals Podman.
Oh, that's a nice convenience.
And that means that the command will operate in Podman mode.
Yeah. So it's still the same Scupper CLI. It's just talking a different language because you're talking to Podman instead of Kubernetes.
Exactly.
Yeah, that's really cool.
Awesome.
Yeah. So this over here, I'm going to create the token. We'll call this a.token. It can be the same thing. You can overwrite the old token too. It doesn't matter because it's spent. But and here I need to initialize this guy, and again I'll set the ingress to none. Oops. So there we go. It's initialized, and if I do Podman PS, you'll see some of the same infrastructure showing up in Podman. A router running here alongside my backend. And now I need to create the link. So it's link, same procedure. A.token. I'm here. Okay, that's good. And now I can expose my my pod running the backend. So it's Scupper expose host, and I need to use the name of the container, which I called Hello World Backend. Expose it under the address backend, and the port is 8080. So if everything's working, if I pop on over here, I say hello a few times, you'll start to see more than one worker. So Wacky Worker, that's the backend running on Minikube. ANSI application is the worker running on my on Podman.
And when you exposed the new backend, it automatically started routing traffic to it. We didn't have to do anything different at the front end level. We didn't have to change anything there. I assume there's rules that can control how much traffic goes to each one, stuff like that.
Yeah, by default, it's based on it's not like some people think. It's not round robin. It's looking at the backlog of how busy is the backend that's servicing the request, basically. Right. So if it's taking a long time to respond, it will get fewer connections forward to it. And you can configure, there's this thing called link cost that you can use to configure how those connections are, how the balancing is computed.
That's gosh, what am I thinking of? It'll come to me eventually. There's other things that are similar, right? Service mesh being one of them.
Yep.
Why can I not think of the thing that I'm trying to think of? Brain work. And I'm out of coffee too. Yeah. No, it's really cool that you have that amount of control, at the application level, as an application person with what it's doing there. Does Scupper create a new router and controller for every new link, or does it use the existing router and controller?
It uses so when you create a new link, that's really just decoupled from the router. You have a router per site, and then you can have any number of links out from that site to other sites.
And is that namespaced?
On Kubernetes, a site is a namespace.
Okay.
On Podman, it's a particular Podman network.
Okay. That makes sense. Yeah. So Jonny, do you have any other questions? Any other thoughts?
No, I'm excited. I can't wait to see how people start using it. I think that I think it was Nerlep earlier said that they were gonna spin it up in their lab and kind of kick the tires on it. I'm curious to see what everybody else is using it for and how they use it and what their experience is. You made a point earlier, Justin, about migration, right? And I think that I can definitely see this. Just thinking, for those that are still on OpenShift 3.11, trying to move to OpenShift 4, right? Like I can really see that being that bridge, or that
That was the first use
gap.
case from the first customer.
Yeah,
That's
awesome.
They didn't want to have to pick everything up at once and migrate, so they did it one service at a time.
Yeah, and that makes complete sense to me, right? Like that's 100% valid use case, because it's like, okay, cool. Let me drip this stuff over instead of just flood it over and then try and figure out and pick up the pieces and figure out like, okay, what did I mess up? What did I break and stuff like that. Now I can just take my time and get my stuff over there and then, shut down when I need to. And that's amazing.
The way it works is kind of cool. So you set up, you basically introduce Scupper into both environments, the old one and the new one. And then you migrate one service, and that one service is then servicing traffic. Sorry, that you can service traffic for that service from both locations for a period of time, right? To ensure that they're both working, including in the new site. And then if it's working, that's great. You can tear down the pod in the old site, and it's migrated. That one service is now migrated. If it's not working, you can just roll back. You can say, okay, that service, that individual service migration didn't work. Just peel that back. And then you just repeat the process for each service, and at each point you're safe.
Yeah, and to be clear, that's not just for OpenShift 3 to OpenShift 4 migrations. It's between any clusters, or between
anything.
Yeah, between bare metal and Kubernetes, or doing development, or even because this never happens, production, on a local Podman or something like that, and you want to move it into Kubernetes, that type of stuff.
Yeah, it sounds awesome. It really does. Like I'm excited. And one thing that's cool is on the Scupper site, they have all these examples and things that you can go through and use and stuff like that. Do you know, are we doing stuff like that on the OpenShift side? Like are we putting, like if you go to Scupper.io and they have all their examples, they have like Nginx and a couple other things, like are we doing something on like developers.redhat.com where we kind of take that and make it work with all the security stuff that comes with OpenShift out of the box?
Yeah, there's it's not as far along as the upstream project is, because we worked on that for a long time, but the team at Red Hat has really sprung into action to make developers.redhat a lot more complete for Service Interconnect. Awesome. And they have a bunch of those like getting started guides and examples.
Awesome. Oh yeah, it says right there, 3.11 to 4 migrations. My bad.
no, that's good. The thing I'll say about use cases is that networking is kind of like a fundamental utility in the world of computing, obviously, and so that ends up meaning that for something like Scupper, there are a lot of use cases. These aren't. I try to offer some specifics, but these are kind of broad families of functionality that you can consider.
Mm-hmm.
The big one for me is that one in the top left. So we, because of the way layer 3 networking or infrastructure layer networking works, it's easy to end up with something you care about in a place you can't reach. Yeah. And that's just a great opportunity to use something like Scupper. It's, if you have a database and that database is relied upon by other applications in your organization, so it cannot move to the cloud, but you still want to develop a new application that runs in the cloud, Scupper is a way to do that, because Scupper can give you access to that database right where it is, and it will just make it appear as though it's running in the cloud next to your new components. And that's a class of migration that people can consider doing now.
Yeah, that's something like, even yesterday, I was talking to somebody about some of the, like, we were just talking about like a range of things, but that was a use case that I'd actually brought up yesterday. Like, if you have a database, like, you can make that, essentially you can keep that on your cluster locally, and then have something reach in and access it, or vice versa. You could have an RDS and then have your on-prem clusters reach out to it.
Yep, absolutely. Yep.
I don't know, I'm still digesting the application resiliency, the HANDR approach of, can I have a more or less a hot standby, of my application that's running, and effectively, I join both of those sites to the network and to the link, and now I just rely on Scupper to transparently, when one side disappears, it just keeps running, it keeps going because it moved over to my alternate site, stuff like that.
It can do that, and there's really two things to think about there. There's service availability and then data availability. So for service availability, Scupper, that's a great fit. Like, so if one of the backends for that service or one of the targets is unavailable, then it'll route to the one that is available. For data, a lot of applications have their own protocols for replicating data across sites, locations. And that's where Scupper helps you, just because of its connectivity potential, right? You can replicate that data to a network location that you might not have been able to reach before.
Yeah. To be clear, it's a network technology, not a data network or a data replication, anything like that.
Exactly.
Let's see. Akram, does Scupper use similar mechanism to what was done with Zero Tier? And thank you for joining, even if it is late, Akram. We talked about Zero Tier and Tailscale are kind of similar. So yes and no. I'll let you elaborate, Justin.
I would say no. Well, I mean, I don't know exactly how Zero Tier works, but it's not like Tailscale.
Okay. Oh, I didn't know that. So I clearly don't know very much about Zero Tier.
No, well, so
oh no, sorry.
Functionally, you believe it's like Tailscale, right? Because it does the same thing sort of functionally. There's no VPN technology or any of that kind of stuff under the covers here, right? No.
Yeah, and maybe I sort of misled you slowly. The Scupper is not like Tailscale in that the transport is
Totally
much different from what Tailscale uses.
That's a good point. So words are important, right? So implementation wise, they're very different, but in concept, they are similar. Right. The concept being to allow endpoints to communicate with each other regardless of where they are and what's in between them.
Yeah, I think that's right.
But things like Tailscale and Zero Tier use VPN to provide what is effectively layer 2 adjacency, layer 3, connectivity, as though there is nothing in between them, or there is little infrastructure in between them, as opposed to something like Scupper, where I am talking to an endpoint, a service, a DNS name, and through the magic of Scupper, which is effectively, the service framework in Kubernetes doing routing over to wherever those are, the routing here being Scupper, sending data to where it needs to be.
Functionally, Scupper behaves as a proxy on both sides, right?
Exactly. Yeah, you can see how those are so different, right? Like, we're not giving you anything like an IP local to your host. You're not getting that IP adjacency. What you're getting is, depending on what you care about, a connector or a listener that ends up forwarding traffic to another component of your application.
Yeah, and I think it was on one of your slides, or maybe you said it before. It's a service, right? It's a named endpoint that you communicate with, not an IP address.
Correct. Right.
So no, that's I think that's an important distinction to make. Yeah, so I know we're coming up. We're at 76 minutes at this point. So normally we're trying to wrap up about now. So if anybody has any questions, if there's anything that comes to mind that we didn't answer, I don't think we've missed any questions as we've been going through.
No,
Please feel free to ask those now. So if you're not watching us live, or if there is something that comes to mind after the stream ends, for anybody who is watching us live, you're more than welcome to reach out to us at any time. Jonny especially loves to get email. It's his favorite thing ever. So send all of the emails, and you can include me too, I guess. You can add me to CC. But you can reach Jonny at JONNY, just like you see on the screen there, at redhat.com. You can also find Jonny at JRockTX. I'm digging around for my little pop-up thing here, Jonny, and I'm struggling. There we go. I got it. At JRockTX1 on all of the various social media platforms. If you are, for example, on the Kubernetes Slack channel, which will toss up the little thing for that here as soon as I find it. If you are on the Kubernetes Slack channel, for example, Jonny posted a message in there this morning about this live stream. So you can find him that way. If you would like, you can also reach out to me at andrew.sullivan@redhat.com. And, super simple, first name dot last name for me. Not everybody has that. So, don't be randomly throwing out things. You never know who you're going to get. But I do have andrew.sullivan@redhat.com or at Practical Andrew across all the various social medias. We're also Jonny and I are on Reddit and various Kubernetes Slack channels and all of the social media platforms and LinkedIn and all of those other things. I guess LinkedIn is a social media platform, right?
Yeah.
So
professional Facebook.
Yeah. It is kind of professional Facebook, isn't it? Spartan got a question. Yeah, ask away. We've still got a couple minutes before we'll end the stream. This is something that's really interesting to me. Like I said at the beginning, I really like the idea. I like the concept of, and I feel like many things in Kubernetes and OpenShift are about this, but giving the power to the application teams. It's not handing over the keys to the kingdom. It's getting the infrastructure, getting the platform out of the way so that they can do the things that they need to do. And this is a perfect example of, instead of having to, okay, I've got some application components in Kubernetes and some that are in virtual machines and some that are in physical machines, and they're across all of these different infrastructures. And now I have to talk to 3 separate teams, 4 if you include, firewall teams and all this other stuff, in order to try and get all of my parts and pieces to communicate. Instead, now I can self-serve all of those things. How many years have we been talking about DevOps and pace of innovation? And if you've got good eyes, you can probably spot, the Phoenix Project somewhere in all of these books behind me, and all that other stuff. So it's another example of handing over a controlled amount of configurability, connectivity, right? Keeping everything secure, keeping everything reasonable. I do wonder, one thing that comes to mind is from a troubleshooting perspective, like how much is there to troubleshoot? It feels like it's pretty straightforward. Either the link is there or the link isn't there. And if it's there, it probably works.
Well, there are things that can go wrong. We've run into cases where people can misconfigure it or put it in a configured state that's not going to work well. So we are constantly trying to improve the tooling to point those issues out, and make it easy for people to say, this is what went wrong.
Yeah, look here.
Look here, exactly.
Yeah.
Yeah, well, that's the whole thing. Gosh, what is it? I can't think of the name of the types of AI or machine learning that help you identify where a problem is faster. It's not, here is the problem, here's how to fix it. Rather, it's, you should probably look over here type of thing. Anyways, I was catching up on chat, so I only partially heard your comment.
So Spartan asked his question, or their question.
Yeah. How's the first day in Red Hat? My first day in Red Hat was to go to new hire orientation. So it was being inculcated to the cult of open source, which was a lot of fun. So it was, gosh, when was that? 2018. So we all collected on the 8th floor of the tower and spent 2 days learning about open source and how Red Hat operates, and got our fedoras, so the infamous fedora that everyone gets when they join. So yeah, it was a lot of fun, and I still keep in touch with a lot of people that I went through New Hire with, even though we're from all across the company, which is really interesting.
Yeah, same. I came in 2016. I actually just hit my 7-year mark at the end of July, and yeah,
Congrats.
I was nervous and scared, and then I was like, "Oh man, I'm gonna be found out," But and then everybody else is gaggled up in the lobby, and everybody else is scared and nervous, So I was like, "All right, okay."
Yeah. Did you get the orange badge so that way so you could go into the cafeteria and get
Yeah.
lunch on the first day? And yeah,
Which is an awesome cafeteria, by the way. Like the sandwiches were awesome.
the Hat Rack, Hat
Oh,
Rack
yeah.
Cafe is awesome.
Yeah, I love that.
I don't know, Justin. Justin, how long have you been with the company?
Well, so I've been here in 2 stints. I've gone
boomerang.
through, new hire orientation twice. Let's see, and right now I'm up at I have one of those 15-year pucks, but it's a lie. I've actually been at Red Hat, I think, 18 years.
Yeah, well,
Nice.
the last company meeting. So, anybody who isn't a Red Hatter doesn't know. So at company meetings, we have a video that plays at the beginning with all of the service anniversaries for folks. And the last company meeting, there was, I think, a 40 or a 45-year service anniversary, to which somebody said, "But Red Hat isn't 40 years old." Well, they inherited from IBM.
Right. Okay.
So yeah, now that Red Hat is owned by IBM, they inherit all of the service years from IBM, which I thought was interesting. Jack, not to call you out, how long have you been with the company?
Since 2012.
Okay.
But like the guy from IBM, I inherited some service years, so I've got 15 or 16 years.
Wow, man, I'm the short timer here. Then I'm the new guy.
Yeah, just a pup.
Like I got some things to learn. Let's see. I thought I saw another.
We have one
question
more
here.
from
Yeah.
Akram.
How is name resolution happening in Scupper?
So what Scupper does is use the naming facilities of the particular site. So in Kubernetes, you have kubedns and services, right? So it's going to create a kube service and use kubedns to offer up, a component that you've named. And you saw me, use that address or that name in the commands. That's what we're using. In Podman, we use Podman networking, which there's a Podman network, and then it uses the names or aliases associated with the pods that are running, or the containers. And so that's kind of the whole story. You use for each site type, you use whatever the native naming facility is for the networking.
Yeah. So within Kubernetes, it's the service framework. You create a service, and that provides the resolution there.
Yep.
And a random thought that just occurred to me. So if in the demo you gave, you had OpenShift as the front end and Minikube as the back end.
Right.
If I were to add, so in the Minikube instance, if I were to add 2 or 3 or 5 or 10 additional instances of the backend service, it's still just one service that's running on that backend, and basically it still relies on the native Kubernetes service framework or service implementation to distribute traffic across of those. I don't have to create a new Scupper, expose a new Scupper instance for each one of those new pods that gets created.
Correct.
Okay. Is there metrics about latency and performance with Scupper? Higher we go in the OSI model, more difficult to manage latency and transport problems. That's a good. I like this question, Akram. Is there any discouraged use cases or instances where we shouldn't use Scupper? Well,
I don't think there are instances where let's see. So if your application is based on UDP and you need a lossy transport, that's not a good fit for Scupper. Not right now. And that could possibly change if we change Scupper's transport in the future. But I think if you need UDP just for compatibility with an application, and you're okay with it riding inside of a mutual TLS TCP based transport, then that works well. But if you're relying on the low latency and lossy aspect of UDP, it's not currently a good fit. But my more general answer to that question is, it's not so much about the latency and performance of Scupper, though you should look at that for your application. The real bigger concern you should have is if you're separating workloads in to different sites, geographically separate sites, you're already going to get a bunch of latency just from the fundamentals. So that's the first thing I would worry about. You need if you want to modernize your application, you might want to set up something in the same data center on a different platform to reduce the latencies.
Yeah, that was something, we talked about it a lot a decade ago when microservices, 12-factor applications first it really started to become popular on-prem, breaking up monoliths, if you will, of, hey, everything went from being on, one gigantic server, so communication across different components was effectively instantaneous, to, now I'm distributing it across all of these microservices. Is there going to be a bunch of latency added in, and is that going to affect the application? So I feel like a lot of app teams have kind of figured that out, but now we're taking it, an entire magnitude. There's the word I was looking for. A whole nother magnitude of additional, potential latency when you're crossing, maybe subnets within the data center, potentially different data centers within the same org, or even, cloud to on-prem or vice versa.
And it's very application specific. I mean, there's a lot of code out in the world that is written in asynchronous, remote procedure call fashion.
Yep.
And that's always, that's going to make your throughput a function of your latency. As your latencies go up, your throughput drops, and you'll struggle at times of peak throughput.
Absolutely.
So that there's kind of an application architecture dimension to that too.
Yeah, I like that. That's always it's not just throw more infrastructure at the problem. Sometimes the application has to do things to fix it.
Yeah.
I used to do a talk about how, every time you add a 9's worth of resiliency and redundancy into the data center, it's an exponential increase in the cost. And so, is it more cost effective when you go from 4 to 5 9's to throw more money at the infrastructure, or to go and talk to the app team and say, hey, can you do these 1 or 2 little code changes and, maybe help us get that extra 9 at the application level?
Yeah.
Spartan, how can someone with less than 1 year of experience enter into Red Hat? So if you're talking about Red Hat, like as an employer, it's pretty straightforward. Just go to, I think it's jobs.redhat.com is the portal.
Yep, I'll paste it right now.
Yeah, we don't have an internal jobs portal or anything like that. Everything gets published externally. And I would just encourage you to apply for anything and everything that you think is a good fit for your interests and your skill set. I know when I hire people on my team, I always, people say, oh, well, I know Kubernetes, or, oh, I know Linux, or, oh, I know these things, but I don't know Red Hat Enterprise Linux, or I don't know OpenShift. And literally there's no better place in the world to learn OpenShift than at Red Hat. It's very much a, what's the role, what's the type of skills that we're looking for, that type of stuff. Justin, I'm sure you can talk about on the engineering side far better than I can, because on the business unit side, it's a little bit different, but.
Well, Red Hat prizes open source from the engineering side, open source contributors. So if I were you, I would plug into an open source project I like that has like a level of impact for the people writing modern applications, and just try to build some comfort there. And then opportunities like Red Hat will open up.
Yeah, that's a good point. And you can tell I'm not in engineering, because like engineering, open source contributions, they're, you go and look at GitHub history or something like that, and you can clearly see when and where and the types of contributions that folks are making from an engineering perspective. In my 30s, someday get into Red Hat. And hey, I was in my 30s when I joined Red Hat. So
into my 30s.
Absolutely. Yeah, absolutely. Yeah. You can.
Yeah, I thought, and that was my fear coming in, right? I was like, I'm going to be the old dude going there,
Not even close, bro.
Yeah, exactly. It's funny how like you've got this picture in your mind of like what it's going to be like, and then you get here and you realize that it's just like everywhere else. Honestly, I mean, it really is. It's just, except cooler, but like, the people, like I thought people were gonna just be monsters. I don't know. I just had this whole vision in my mind that it was gonna suck. But I got here and it's been awesome for me. I love it here. Red Hat's gonna have to fire me to make me leave. So.
It doesn't matter how old you are, right?
Yeah.
You know, I 100% get. You know, I will admit that I more or less had a career change a decade ago when I was in my 30s, early 30s. You know, I went from being an administrator and, you know, storage administrator for day to day over to tech marketing. So it was a fairly, you know, still technology related, but a fairly significant shift inside of technology. So it's entirely possible. Nothing, no worries there, I should say.
Yeah.
It might take a little bit more time. And I would say if you're in a senior role now and going into an entry level position, clearly things like compensation might be an issue. But
yeah, and that's kind of. Oh, I'm sorry, Andrew.
No, I was going to say that's usually the challenge when people change, you know, make significant changes in their career, you know, later on.
Yeah, and I had a similar thing where like I went from being technical to I was a tech director, so more like a CTO, you know, for a region, and then back down to not back down, but you know, I made the change back to being technical, and I you know did that for a little bit, and then came over here. So it's definitely doable. And the thing about Red Hat is that like people are happy that you're here. One thing, like when I worked with the government and I worked with some of the companies within the government, it was be glad you're here, right? That was kind of like the mantra, like, hey, be glad that you've got a job, be glad that you're here. Or Red Hat, it was like, holy crap, hey, we're happy that you're here. We're glad that you're here. Come on in, let me show you this thing. And that's been my experience the entire 7 years, right? I mean, I feel like Red Hat is very much a let me show you how to do this. This is awesome. Come check this out. And people will rally around you and help you out. So it's a good place to be.
Yep. I say at least once or twice a day, like, I don't know. Can you please teach me? And
Yeah.
I have never encountered anyone who has been, you know, sad, upset, angry, anything like that about it. Yeah. It's, you know, everybody's very passionate. We all enjoy what we do. So it's fortunate.
Yep.
So I don't know.
Good questions.
Jack or Justin, I don't know if you have any thoughts or opinions or perspectives on any of that, but you're welcome to chime in if you'd like.
I'll just say that, you know, I'm a manager. I was an engineer for a long time, an individual contributor. Now I'm a manager. Have been a manager for a while now. What I sometimes see on like Hacker News and stuff is people saying, you know, I hate my company because the only way I can make progress in my career is to pick up the management track, and that is not true of Red Hat.
No.
Right? Not even close. Our individual contributors are very highly valued, and you know you can remain an IC your whole career at Red Hat and have the highest esteem.
Absolutely.
Yep.
And in some ways higher than us as managers.
I think so.
Yeah. You know, I'm a manager too now, and it very much is focused on like I accept and admit that my ability to contribute, you know, individual contributor things is limited as a result of that. So my role is really to help all of the ICs, all of the people who are day to day doing that work, to be successful and to really flourish and be highlighted. And you know, it's a great mentality to have. And it's not just me or you, Justin, it's across the company in my experience.
Mm-hmm.
Yeah, ICs are really highly valued here. But well, I think we've run enough over on our normal time allotment here. Our Hope 9. I know you appreciate when we have the longer streams. So, and really great questions today. You know, I especially appreciate both questions about today's topic and the technology, but also kind of things in general. Right? It's always good to talk about what's going on in the industry, what's going on in the company, right? All of these things. So thank you, you know, to the folks who've been asking all those questions. And clearly, you know, Jonny and I are always open books when it comes to this stuff. Justin, thank you and Jack, thank you for sharing as well. So again, for anyone who isn't watching us live, you're more than welcome to reach out. So very quickly, as soon as I find my buttons here, you can reach me at andrew.sullivan@redhat.com or at Practical Andrew across all the socials, or you can reach Jonny at, oops, I clicked too many times. You can reach Jonny at Jonny, Jonny, at redhat.com or jrocktx1. across all of the various socials. So we will be back next week. Next week, we're going to be talking with GitLab, as Jonny mentioned, back at the top of mind topics side of things. We've got a number of super interesting things coming up. Whatever platform you're on, I would recommend that you subscribe, so that way you know when we schedule these things. Although I'll admit that we're not always very diligent about getting them posted ahead of time.
We're getting better.
We are getting better, but I say that because Jonny's better about it than I was. You've been doing a good job at it, Jonny.
Thank you. Thank you.
So, it's when I'm the one who's responsible for it is when things get a little suspect, shall we say. But again, don't hesitate to reach out. Thank you so much to everyone who joined us today. Jack, Justin, this has been amazing. This has been great. I've learned a ton about how all this stuff works. And I'm really excited about seeing these things come together. Tailscale, zero tier, those were things that got me excited as a nerd with, my home lab and all of the other stuff that's inside of there, bringing it into the enterprise and seeing how it can help our application teams, as well as our infrastructure and administrator teams, just be able to do more, be able to do it faster, be able to, do all of the things that we do, make the widgets, do this stuff. It's amazing. So thank you.
Yeah.
Likewise. Thank you both.
Yeah.
Yeah, we appreciate it.
And Jonny, I will leave you with last words while I figure out which button to click.
Yeah, it's hard to follow up what you just said, Sully. Thanks again, guys, for coming on. This was really great for us. And to the audience, thank you for all the questions. And like Andrew said, right, if you ask us a question, we'll try and give you our perspective. It might not be what you want to hear, but we'll at least try and give you our honest, thought on something. Where we can, right? We're not going to go to bashing anything or anything like that, but. Thank you for all the questions. It really does make the stream exciting for us because that's what we thrive on that. So, but Justin and Jack, thank you again. I know that this is time out of your day to do this, so we appreciate your time. Thank you.